Okay, so if our task is to use the Jefferson's method for determining apportionment, we should first find the divisor, and I'll make that different than group D here. The standard divisor, right, which is found by using this formula where you take the number of Senate seats, 36, or the number of representatives. That should equal the total amount of the population divided by the standard divisor. Okay, so what this does, when you solve for the divisor, it's a quick little algebra equation. The divisor is 195,000 divided by 36. So it gives us 5,416.6 repeating. Okay, that's like it takes about 5,417 people to get one senator in each of these groups. That's what the standard divisor tells us. So what we can do is we can first, like we've done probably in a previous problem, we can find out how many people in population in Group A are going to, or how many senators we're going to get in Group A. Okay, so you take the 54,000 and divide it by that divisor, which I'm not going to write down the whole number. I'm just going to write divisor there, okay? Same thing for B. You take the 61,000 people that live in Group B and divide by the divisor that we just found, the standard divisor. That'll tell us how many senators. And then do the same thing for C and the same thing for D. Oops. So let's do that real quick. Let's see if I can... No, I don't have a copy and paste. 5416. I'm just going to copy this to my clipboard so it's a little quicker. 54,000 divided by that standard divisor. So the first group is supposed to have 9.969 senators. With the Jefferson's method, actually what you do is you just drop the decimal. So this should be 9 senators. Okay, 61,000 divided by that standard divisor, drop the decimal, you've got 11 senators. For Group C, it's 29,000 people. Divide by that standard divisor, so you have 5 senators. And then for Group D, it's 51,000. Divided by the standard divisor, you got 9 senators. Okay. So if you add those up, that method of dropping the decimal obviously has some drawbacks, and there's definitely better methods of voting apportionment than this. Okay, that gives us 34 senators, so that means there's 2 surplus. Who gets that 2 surplus? What you need to do is just adjust this divisor, and from what I've read, there's no set method on how to do it. Okay, adjust the divisor until you've got all 36 people set out. So let's guess. And if you really like math, you hate guessing probably. 55,000 is a new divisor. Okay, so if we do that, you've got your A, your B, your C, and your D categories. We'll find out how many senators they get if we use this. If we cancel out this old divisor and use 55,000 as our guess. So 54,000 divided by 55. Sorry, I think I said 55,000. It's obviously 5,500. Okay, so we get 9 for Group A. For Group B, 61,000 divided by 5,500. There's 11 when we drop the decimal. Looks like we're going to fall into the same trap, right? Group C, 29,000 divided by 5,500. You get 5. So it looks like our guess hasn't helped us. And then Group D, 51,000 divided by 5,500. The guess hasn't helped us because we got to the same number of senators. We still have a surplus of 2. Okay, so that guess is bad. Let's try another one. Let's take a guess of 5,000. Okay. So again, for Group A, 54,000 divided by 5,000. So remember, you drop the decimal. That's 10 senators for Group A. Okay. For Group B, 61,000 divided by 5,000. That means we've got 12 senators for Group B. For Group C, 29,000 divided by 5,000. That gives us 5 for Group C. Remember, you don't round, just drop the decimal. Then 51,000 divided by 5,000. We get 10 for Group D. I think we're 1 over, aren't we? Yeah. 10 plus 12 plus 5 plus 10. Yeah, we got 37. We're only supposed to have 36. So we're somewhere, we know it's somewhere between 5,000 and 5,416. So you just got to keep doing that guess and check method. Guess a new divisor, guess 52,000. Not 52,000, sorry, 5,200. Okay. Let's see how many centers do we have in group A. I'm going to just do 54 divided by 5.2 to save myself some typing. So we got 10 for group A. 11 for group B. Still on the same track as the last one. We got 5 for group C. 1 divided by 5.5, sorry, 5.2. That's 9 for group D. I think we got a winner here. 10 plus 11 plus 5 plus 9. Oh no. Yeah, that didn't work because that adds up to 35. So now we got to make a new guess. So let's guess 53,000. So it's kind of like a guessing game, trying to get it in between a certain set of numbers. So we got 54 divided by 5.3. No change there. 61 divided by 5.3. No change there, because remember we just dropped the decimals. 29 divided by 5.3. No change there. And then 51 divided by 5.3. Oops. That's not going to do it either. Same amount. We've got 35. So when it was, oh, actually my guess, actually I know I went the wrong direction, because when we guessed 5,500, we had too few centers. When we guessed 5,000, we had too many centers. So it I should have guessed 51 for this last one. Something between 5,200 and 5,000. Okay, so let's guess 5,100. So we got 10 for the first one. Oh. Got 11 for the second one. Got 5 for the third one. This is painful. We got 10 for the fourth one. Is that a winner? 10 plus 5 plus 11 plus 10. We got 36. How many seats will District C receive? 5. Okay, so finally we got a distribution of centers that works out. Okay, what they give? Yeah, they adjusted divisor. Yeah, they ended up using the same one as we did. You don't even have to use 5,100. You just have to keep adjusting that divisor until you get all the centers displayed. So obviously this isn't the best method, because it doesn't, there's a lot of guess and check involved. Works great for a computer, but doing it by hand takes a long time.